Hey everyone, thanks for coming. I'm going to be presenting without notes today, but I'll try to do my best. So today we're going to be talking about videos, but before we get started, let's get to know each other. My name is Alexey. I've been working as an Android software engineer for the last 7 years. Currently I work at Reddit, where I'm mostly working with video-related content, with video experience. Before Reddit, I was working at Revolut with a platform domain, and I was mostly responsible for CI/CD, Gradle, and testing stuff. And I'm also a Google developer or expert for Android technology. So I really enjoy having new chats. If you'd like to connect, please join me on Twitter. And a bit about Reddit. So from an Android perspective, we've got 700 modules, almost 700, so we're 100% in Kotlin. And recently we have started migration to the Jetpack Compose. We already migrated 56% of the features. And to deal with all of that stuff, we've got 75 Android engineers. And talking about videos, they are literally everywhere at Reddit. So we've got more than 10 different surfaces. And this talk mostly going to cover the stuff we discovered along the way, trying to make it better. We're going to start with a bit of theory about video. We're going to discuss what is the video. We're going to be talking about frames, codecs, resolution, and bitrate, about adaptive playback, and of course, a bit about Android Media 3. Next part going to be practical. We'll discuss practical delivery, caching, prefetching, load controls, buffers, bandwidth mirror. We're going to improve video resolution. We're going to be talking about decoders, and of course, briefly about Jetpack Compose. And my main goal actually give you some practical take-home tips, the things you can implement on your app, probably even tomorrow. Everything is tested through real production scenarios via A/B test, but just in case, you don't need to trust me. Always verify the stuff I'm going to be telling to you because it may be not relevant for your application. Okay, what is the video? On this particular example, we may see that video is rapidly changed a set of frames or images, often being accompanied by audio. And typically, to create such motion effects, at least 24 frames per second required. This standard has been used in the film industry since nowadays, and it's been used even now. Lately, 30 FPS appeared as a new standard for television, and now, of course, we have 60 FPS, which is kind of minimum requirement for our industry right now. You can see it everywhere on games, on mobile devices, and it's not even a limit because modern devices support 90 FPS. But in terms of video, you still may see actually 60 FPS, 30 FPS, and there is one reason for that. Because it's very expensive to process everything related to video. For instance, 1080p video with 30 FPS, 1 second could cost us 1.2 megabytes, and it's just 30 FPS. Just imagine that you have a very long video, and if it was 60 FPS, it would have been twice more expensive. And because it's very expensive, this is not how frames are being processed internally under the hood. We may see that all of the frames has actually content. So in reality, only one type of frame has everything about videos, and those kind of frames called iframe or interframe. It stores everything. Usually it's been followed by p-frames or predictive frame. It stores only difference between current frame and the previous frame. And there is also one more type of frame, which is b-frame. B-frame is bidirectional frame. It stores difference between previous frame and the next frame. And in terms of efficiency, p-frames are way more efficient than iframes, of course. And b-frames are the most efficient frames. And usually companies spend a lot of time trying to optimize b-frame experience just to reduce delivery time to the client side. And while I was learning all of this stuff, I started to work with video only this year, by the way. I was thinking, okay, who is the cool guy who is being processing all of that frames, who is operating them? And the guy named Mr. Codec. Codec is actually short for coder, decoder. Main goal is to compress video on the backend side somewhere and decompress it on a mobile site just to improve delivery time for the clients. There are two types, software and hardware. Talking about software, they are way less efficient, but they support some more modern video codecs. And hardware video codecs, they are actually not going to consume any CPU, which is very good. And talking about variety, there's just a lot of them. You can see how different codecs are spread between different production environments. So in my humble opinion, at AVC, which is more than 20 years old as far as I know, is still a very pragmatic choice, especially if you're not focusing on video. If video is not a main part of your application, if you're not trying to build such app as Netflix or Amazon Prime, so AVC is still a good choice. However, if you still decide to work with VP9 or some other modern codecs which are way more efficient, there is a cost for this efficiency, and the cost usually on the client side and not everywhere it's actually supported. That's why there is always usually a fallback to AVC codec. There is also bitrate and resolution in video. Talking about resolution, so each frame consists of tiny dots called pixels, which forms resolution. And bitrate is the amount of information which can be transferred within an amount of time. And usually, video and audio bitrate has very strict correlation with network bandwidth, which is available on the device. And of course, more resolution practically means that you can afford to have more audio and video bitrate, which is good. Talking about popular delivery methods for the client side and the backend side, of course, you can deliver videos with a pure binary like MP4. So it's very easy setup. It's supported everywhere. It has only a single round trip to the backend side. It's also possible to load video progressively, chunk by chunk. However, it uses single bitrate. It's not adapted for the network changed. And it's maybe not very suitable for longer video content, where you cannot really afford to download the whole file. And to solve this problem, there is adaptive protocols appeared like Dash and HLS. Main goal actually to solve the problem, so they support multiple bit rates. They adapt for the network condition. For instance, you can watch video with 1080p, then you've got less bandwidth, and the quality on the fly may be changed to 720p. However, it's very complex setup, especially on the backend side, and it requires additional round trips. We're going to discuss it soon. So talking about our adaptive protocols, there are two of them which are very popular. First one is Dash, which is developed by Google, which is a younger one. So it works on Android and web. There is native support for that. So it requires minimum 2 round trips to the backend side before video is going to be played. Firstly, it fetches manifests, then it's going to fetch video segments. Practically, actually, it has a lot of more round trips. And yeah, it just doesn't work on iOS, which could be a deal breaker for you. There is no native support. It's possible to support, but yeah, there is just no native support for that. And alternative is HLS, which is developed by Apple. It's a bit older protocol, but it works everywhere. It's supported on Android side as well with ExoPlayer. However, it requires minimum 3 round trips because it fetches master manifest, variant playlist, and video segment. And it's still, it's only minimum amount. Practically, it's more. Talking about adaptive playback, let's quickly review how it works with Dash practically. So we got a mobile device, we got Mr. Backend, and CDN. So first we fetch probably video URLs given by some videos. We select first URL, and we pass it to ExoPlayer. And the first thing ExoPlayer does, it downloads the .mpd file. What is that? MPD file is a manifest, which stores a representation for all video formats you have with a bitrate, and you also can define here resolution as well, by the way, and it stores also audio. Then, magically, somehow, ExoPlayer gonna select proper bitrate, and it's gonna download audio first with those selected bitrate, and then it's gonna download video. And only after that, it's going to be able to show the first frame, which is very expensive. From the other hand, talking about uploading, practically it looks this way. You've got a mobile phone, you upload video in a single quality to the backend side. Backend side usually communicates with some encoding service. And encoding service is going to cut your video to the multiple qualities. It's going to try to increase the quality. It is going to create manifest, and it's all going to be uploaded to the CDN. And to deal with all of that stuff, on Android, we've got Media 3, which is very good. Media 3 is a set of libraries to work not only with video, but also with audio. And did you know that there is 34 libraries available for us in Media 3? Some of them you may already know, like Dash, HLS, VP9. So all of that stuff we're going to discuss now. So let's talk with approaches. But at first, let's answer what we don't like about videos. If you're going to ask me, I don't really like this guy. So it's rebuffering on the most interesting place it happens before first frame going to be shown. But the next one, so while we're watching, on the most interesting place, you're going to see that guy, network error. So which also, actually, we would like to avoid as much as we can. And of course, we'd like to have a video in a very good quality, because it's a good motivator to proceed using your application. And first thing, from my perspective, you need to think about is proper video delivery. Historically, at Reddit, we were delivering everything with Dash. And let's reuse the scheme again. We've got a lot of round trips. And it turned out that all of those round trips are the best friends of Southern One guy. We decided to conduct an experiment and replace some of the video content that we have from Dash to the pure MP4. And the results are pretty impressive. We've got less playback errors. Minus 5%, video view is also increased. What we can recommend here, use MP4s if you have only short video content, if you don't care much about video quality, but if you care about video quality, we're going to discuss how to improve that later. And use adaptive protocols only if you have longer video content. Next thing, which could be very useful, is the prefetching. The idea is very, very simple. While we're watching our videos, we can always observe what's going to be next video and next, and we can prefetch next video while current one is going to be played. If you're going to Google how prefetching works in ExoPlayer, you're going to see a lot of stuff like Dash downloader, HLS downloader, Dash util, and so on. And it's not really clear what you should use for that. So you can start with Download Manager. It's very simple to use. But first, what you need to do is to support proper caching in your videos. And to do that, let's review how ExoPlayer actually works. When you're going to pass URL, you would need to create actually media source, which could be Dash media source, HLS media source, progressive media source, or smooth streaming if you'd like to work with streaming content. Then I'm going to create a data source like HTTP or cache. To that data source, you need to pass simple cache, which is, being honest, not that simple as it's named. Simple cache actually communicates with file system on your Android device. And the data source here is kind of mediator for everything, and you can pass it to Download Manager. And Download Manager can be introduced from the site to your app. It doesn't need to know anything about ExoPlayer, which is very good. Next question, you're probably going to have where to cache. Right, we've got only two options. You can store into internal storage, which is available everywhere, which is isolated from other apps, but don't store anything sensitive in there because it could be easily bypassed. However, system can clean it up sometimes because each application has quota of the information it can store, and if you're going to reach this quota, probably your video cache can be cleared. And to address this problem, you also may store an information in external dir, external cache. System is not going to be cleaning this. It's going to clean this only if you store your application under application folder and if you remove your application. But it's not going to clean it like if you're going to reach some quota and that kind of thing. However, yeah, it doesn't have any isolations, and it's not available on every device. For instance, on some of the Chinese vendors, you still need to have a fallback to internal dir. And when you create simple cache, you just need to pass that folder, that file, either internal cache or external cache. And next one is latest recently used cache vector, which is, from my perspective, very important because it takes around 20 minutes actually to fill all of that cache for 500 megabytes. Of course, depending on video content, but if you're gonna watch video with a higher quality, so it's better to not annoy your users and always have some eviction. You also need to pass some standalone database provider or any other database provider because ExoPlayer needs to associate actually path to the segments with the file storage. And some of the learning with simple cache. So internally, that guy gonna hit file system because it's gonna check whether folders that you provided to work with is accessible or not, if it's locked or not. And yeah, you're gonna have a lot of timeers if you're not gonna do it on TIOS thread. Second one, if you sign your video URLs to prevent the content from being stolen, which is very important, you may want to use that cache key factory and define how to calculate the cache keys because URL, which is always different, may not cover all of your needs. And you need to do that to increase video cache hit. And talking about download manager, so it's actually very cool because it can manage everything. So you can pause downloads, resume downloads, remove downloads. Download manager, which is part of ExoPlayer, not of the Android system. It also supports parallelization and trading. For instance, you have a lot of options. You can download the same video, but multiple segments in parallel, or you can download even 2 videos in parallel. So you have a lot of options to experiment with that. And it also works for Dash HLS, which is fine. However, it's not as flexible with adaptive protocols because it's still going to download everything that you have in manifest, which is can be very, very expensive. To address that, so I would advise to use download manager for MP4s, but if you need to prefetch adaptive protocols content, so use download helper because you will be able to select the proper track. It's paired with download manager, because you can pass the result of that to download manager. However, you can't define how much data you need to download. So ExoPlayer supports it though, but it's some low-level abstractions. Ideally, we would like to have some methods like download that video, like 30% of the content, just to be able to experiment more with this. And you still need to select track manually via track selector. And usually when we play with ExoPlayer and call prepare, we don't need to do that. However, with prefetching, we are not that flexible. I mean, we are very flexible, but yeah, we just need to write a lot of code to make it work. And talking about prefetching, so it's actually also quite good results. So we got to improve time to the first frame. And video view is also improved, so definitely do that. So it's going to be helpful. And next things we were thinking after prefetching, what if we're going to introduce bandwidth-based prefetching? Would it be better or not? And the idea is simple. We're going to check network bandwidth. If it's good enough, we're going to call prefetching. If it's bad, we're not going to do anything. And we conducted this experiment twice, so with different options. And it actually doesn't work, unfortunately. So time to the first frame increased in all of the cases. So don't spend your time on that. So yeah. For the future, I think some of the ideas that we haven't tried yet, you can prefetch next and videos, but partially, like 5 or 10 seconds each. You also can think about, can you download them in parallel to check multiple options, if it's going to be better or not. And yeah, I can download segments in parallel. And one of my favorite options that's not listed here is you can also introduce CMCD protocol for your CDN. And potentially, you can tell CDN, hey, here is next video. Could you please move it to the bucket which is close to the user? So you can gonna have prefetching from both sides, from CDN side and from the mobile side. Next thing is load control. So what is that? Typically, it's managed how data is going to be buffered with ExoPlayer. And it answers on 2 very important questions for us. First one, should I continue loading that video? And second one, should I start playback right now or not? And very good news for us is it has a lot of customizations. How it works? It has blocking buffering. At first, when you're going to pass the URL to ExoPlayer, so it's going to fill at least 2.5 seconds to ensure that it's actually preloaded. And once it's preloaded, so playback going to be started, but at the same time, ExoPlayer going to backfill some non-blocking buffering for at least 50 seconds by default, and it's going to be moved within the current playback. So it's always going to ensure that at least 50 seconds are going to be preloaded. And there are two flags to manage blocking buffering. So it's a min buffer and a max buffer. Min buffer is actually responsible for the information which is always should be backfilled, like 50 seconds. Max buffer is there's a flag which is responsible for just maximum stuff. So ExoPlayer is going to stop download if it's going to reach that limit. But you may see that those flags are equal to each other because practically it was proved that like if you're going to keep them equal, the user is going to have less rebuffering. So it wasn't like that always in ExoPlayer. Second one is blocking buffering. There are two flags that you can play with. First one is buffer for playback, which is 2.5 seconds. It affects mostly user behavior, so it's responsible for the first frame when video just started, and then if user stopped playing video by stop button, ExoPlayer is still going to use this kind of value. But there is also buffer for playback after a buffer. If your playback was interrupted by network error, ExoPlayer is going to preload at least 5 seconds, going to show rebuffering, and only after that, playback is going to be started. What you can do with that? You can change all of those values. You can experiment with them. Please do that, because mostly those values are selected in ExoPlayer to cover most of the needs, right? But it's maybe not very suitable for you. What you can do, you can change buffer for playback to 1 second, see how it goes. You can check buffer for playback after a buffer from 5 seconds also to 1 or 2 seconds if you have like short video content. You also can adapt min and max buffer. For instance, at Reddit, most of the content that we show to the users is actually like it's going to be under 40 seconds, and 50 seconds it's a lot. So you can change that, but ensure that you're going to keep them equal to reduce rebuffering, and set that flag to true. Because by default, ExoPlayer is going to count actually how many bytes it's loaded, and it's not going to operate in milliseconds. Talking about the results, by the way, I just got them today. So time to the first frame improved a lot. Actually, you can see that we reduced count of videos that loads more than 1 second, almost to 10%. And we just simply were playing with flags that ExoPlayer has. Definitely do that. Oops, some animations. So from the code perspective, what do you need to do? You just need to introduce actually your own load control. You just need to pass all of the values. And that load control you can pass directly to ExoPlayer. Next thing is bandwidth meter. What is that? Bandwidth meter is responsible for calculating the overall bandwidth you have on the device. And internally under the hood, it uses results from different playbacks, and it uses median of that. Let's check it on the particular example. So with the dash playback, in this scheme, after we downloaded the .mpt file, internally ExoPlayer gonna call, OK, bandwidth meter, give me some bitrate that we have. And based on that bitrate, audio track gonna be selected and video track gonna be selected. And after we finish with all of the downloadings, we're gonna call on transfer end on bandwidth mirror internally, and bitrate gonna be reevaluated and stored to that buffer. And it turned out that we implemented prefetching before, right? Most of the content actually is gonna be prefetched, and prefetching is not gonna contribute to bandwidth at all unless you actually gonna introduce that. And to do that with download manager, when you create that, just ensure that you use the same transfer listener in HTTP data source factory, because otherwise, in most of the cases, you're just going to see not very good video quality, especially if you have mixed content, you have Dash and HLS, and you have MP4s. Talking about results, pretty good actually. We were able to improve video resolutions, and the video view is also improved, just one liner. Do that. So I wish I could have my speaker notes to see what's going to be next. Next one is initial bitrate. I was curious how it works actually, because when our application is going to be started, we don't have any information about bitrate. And if you take a look inside bandwidth mirror, you're going to see this stuff. So it actually stores default values for different type of networks. And for each country, it's going to select actually different values. So somehow they actually have been measured by Google in the past, right? But it's maybe not very relevant. For instance, for the UK, for 4G is faster, 3G is faster than 4G, which is, I don't know, at least questionable. And we decided to measure that. And for instance, for the Great Britain, for the Wi-Fi, hard-coded default values 4 Mbps, while real one, which is median, 30 or 50. And what you actually can do with that, you can define actually what initial bitrate you can use. You just need to create your own bandwidth mirror, but just ensure that you're using only one instance, because otherwise your bitrate is not going to work across multiple playbacks with ExoPlayer. Some of the ideas to experiment that I haven't tried yet with bandwidth mirror. So should we decrease initial bitrate to ensure that that video first frame going to be played way more faster, and then it's going to be adapted by Dash or HLS in the case of adaptive protocols or not? Or maybe we should reuse just latest known for network type per particular user, which is going to be actually accurate. Or we can actually use some threshold as well. So that's all questions. I don't know answers on that. If you experimented with that, please find me. So it's very interesting to know. And there is also experimental bandwidth mirror introduced since recently. And typically, bandwidth mirror, which is the older one, has a lot of issues with calculating bitrate. It's not working very well in parallel. And sometimes you may have a case when you have good network bandwidth, but for some reasons, video is selected with not very good quality. So don't use experimental bandwidth mirror yet, because it has issues, but eventually they're all going to be addressed. Next one is improving resolution. So what can you do with that? Let's come back to our scheme. And what was the main idea? We introduced MP4s, but we would like to improve video qualities for our users. And when we request in videos, actually what we can do, we can request all of the information in that request for the video batch. We can request information about bitrate. We can request information about resolution and so on. And then we don't need actually those requests. We just need only one request. So at first we're going to calculate the bitrate. We're going to get latest known bitrate for bandwidth mirror. And after that, we just need to write a logic where we're going to match the bitrate. We're going to select the proper video URL, and we're going to have only one round trip. Very nice idea. Practically, it didn't work as good as we expected. We've got better video resolution plus 40%, which is a lot. However, yeah, time to the first frame decreased. So, and don't use exact values to match them, because we use exact values. If you have 5 Mbps on the device and 5 Mbps video supported, yeah, let's play that. But on the reality, what's actually going to do next, we're going to try to experiment with bitrate thresholds, because you may have a lot of HTTP requests as well, which are not taken into account. And we're going to see how it works, and actually it's going to work fine, I think. So what else you can do to adapt the bitrate? Basically, they're talking about adaptive protocols for longer video content. Zero flux introduced. So like, how soon should you change the quality for the better one or for the worse one? You can also experiment with that. Next thing is decoders. What is the main problem with that? Let's come back to our scheme. So basically, when we fetched everything, video is not going to be start playing like right now, because we need to decode this. And while it's going to be decoding, you're still actually going to see that loading bar. which could be annoying. And once it's done, video playback is going to be started. Talking about problems, sometimes hardware decoders is not going to be available on your device for the different variety of reasons, and one of them is, of course, different vendors or different applications that still hold actually such a decoder, and you're going to have playback error 4001. And there is actually a flag in ExoPlayer, only one, which able actually to reduce this error. How it's going to work, basically, if main decoder is not available, at least you're going to switch to a fallback decoder, which is a software one, which is not as efficient as hardware, but still your video is going to be able to play, which is better. Talking about results, so we were able to decrease the error almost to 100 cases daily, which is good. Last part is about UI. And where actually should we render video? We've got actually only two options in Android. We can do that to texture view, which supports some kind of animations, which is good, which is very simple to use because it behaves as a regular view. However, in terms of performance, it's not very good. So it consumes a lot of battery. There are measurements for that. And then it's not going to support DRM. You can support it by your own, but I'm not sure that you'd like to do that. It's going to be a very expensive task for you. And we also have Surface View, which actually has very great performance. It supports DRM. It's more accurate in terms of frame timing. And however, it's not just a regular view, because by default, your application going to create some copy for the UI, and that UI is going to be synchronized with GPU on real time. Texture view, you're going to do that as well. It works fine when you work with regular views, like with buttons, with text fields. But if you work with videos, it is not as efficient. So what Surface View does, it's just going to skip actually that kind of caching in your app, and it's going to render directly to GPU. That's why it's efficient. However, from my perspective, it's a bit complex. So it's not work everywhere. For instance, if you need to support some animations, they're still not properly supported, and they work only fine on API 24. Talking about recommendations to that, try to see if your video is going to work fine with Surface View. If it's not, you just need to have reliable reasons why you should proceed to work with Texture View. And if you work with Texture View, try to identify the reasons why you're still using that and plan your migration to the Surface View. So next one is the Jetpack Compose. By default, ExoPlayer provides a lot of stuff to work with video controls. Everything is synchronized. But that stuff is actually implemented in XML, which is fine, by the way. So, however, we don't have any support for Jetpack Compose yet. Oh my God, Jetpack Compose. It should have been Compose. Sorry for that. So you still need to work with Android View. However, talking about Recycle View, if you need to support videos in the list, it's actually able to reuse already inflated views, which is fine. And with the Jetpack Compose, since recently, you actually also have that view pool support. All you need to do is just to overwrite on reset and update flux, and that's it, and it's going to work. So by this, you're going to be able to reuse already created, already inflated instances. By using view pool, we were able to improve junkie frames by 30x time, which is a lot, and frame rendering also improved. Always use your own controls. Don't use actually existing ones, just to reduce that inflation time. And talking about other things, so as you can imagine, everything you need to work with, you need to ensure that it works fine, because it depends on the content you have and so on. So you need to do analytics first, and the very important metrics that's going to be interesting for you is time to the first frame, rebuffering, playback errors, and the watch time. Everything you should check over those metrics. There are a lot of ways to use ExoPlayer. You can use ExoPlayer on a single instance per app, which is fine. It's maybe not very suitable for you because you need to implement thumbnails and so on. But in terms of through using of different decoders, they are still going to be preheat, which is very good. So there's also some links that could be interesting. And that's it for today. Thanks.